Okay, AB, this is 13, 14, and 15. Not because they're related, but because honestly they're all kind of easy and I can make a quick video. Number 13, no offense guys, but this is sadly easy, okay? Continuous means one continuous piece. You can't pick up your pencil to draw it. It doesn't have any holes or breaks. Duh, this is definitely continuous. Duh, that's silly, sad, easy. Okay, differentiable means smooth and curvy, no sharp points. This is not differentiable right there. Okay, so figure out which one says it's continuous everywhere but not differentiable everywhere. Is it continuous and differentiable everywhere? Nope. Is it continuous but not differentiable everywhere? Yep, I think I found the answer. Yep, it's B. Sorry, peeps, but whoever asked that question, that one wasn't a very good question. I guess maybe you forgot, but I'm a little discouraged. Moving on to number 14, which is also easy, but maybe you just didn't quite understand the way it was phrased. Here we go with 14. This one is more of a mistake on my part, because this is an easy question, but maybe you just don't quite understand the context, and that is my fault for not showing you more of these already. Okay, what are all these symbols down here in any one of these suckers? Okay, F of 1 is just talking about the height at 1. F prime of 1 is talking about the slope at 1. And F double prime of 1 is referring to the concavity at 1. Okay, so at 1, right here, this point right there, the height there is 0 or pretty dang close from what I can tell. F prime of 1 would be the slope there. Pew! All that matters is it's positive. Okay? The second derivative, though, at 1 refers to the concavity, and this is concave down, which means the second derivative is negative. Put those guys in order. A negative number first. So the second derivative is the smallest value. And next would be the value that's actually 0. This guy was supposed to be a 1 right there. And then the last one would be the thing that's positive. Okay, it's really just a matter of comparing. Again, this would be height at 1. This is the slope at 1. And this is the concavity at 1. Okay, hope that helped. Moving on to number 15, which is another calculator problem. I'm not going to do a great job of explaining that without it. Okay, first of all, you got to know how to plug that into your calculator. But the second most important thing, well, actually maybe more important, is knowing the definition of concave up and what that looks like on the original function versus the derivative. So there's two choices. Concave up means second derivative is positive. Okay, well, this is the original function. On the original function, second derivative positive just means holds water. So you can graph the original function and look for where it holds water. The problem is figuring out where the inflection point happens or where it changes concavity is difficult to do. It's an estimate. Now, since it's multiple choice, you might be able to get away with just looking at it and looking for where it looks like it's holding water versus, well, the opposite, I guess, not holding water. All right? So that's one option. Just eyeball it and hope for the best. The more accurate option is to graph the first derivative of this and interpret it that way. So to graph the first derivative of that, you use n derive. Find the derivative of all of that junk that's written up there, that big old thing, which you're going to put it into y1. Okay, so now graph the derivative. You're going to put this in y2. We're calling this y2, okay? y1 is going to have the original function. In y2, you're doing the derivative of that, n derive of y1, okay? Now, when you pull up n derive, which is math 8, it's going to give you that derivative symbol. What you're actually going to plug in there is the derivative with respect to x of y1 evaluated at all values of x. You're going to put that into y2 and graph it. You might also want to unhighlight the y1 where you put the original function. So now what you have in y2 is the derivative of y1. You now have graphed the derivative of this. So in y1, you have the original function that was given, but highlight the equal sign or unhighlight the equal sign. And now just graph y2, which is the derivative of that. Okay, so what you need to know is now the graph you're looking at is the derivative. So you're now looking at the first derivative graph. Okay, the graph you're looking at is a first derivative. That's the graph you're looking at in that window. But the definition we were looking for was concave up. So we're looking for second derivative positive. Second derivative issue on a first derivative graph means you're looking for slope positive. So you can look for where the slope of this graph that you're looking at is positive. Okay, and it should be the same answer as the other one you were estimating. So there's two options for doing that. Again, that's not the easiest one to explain without being in front of you. That's my best bet, but you might have to ask me to do that one again in person. All right, hope that helps. Sorry if it didn't. Keep asking, don't be shy.